Hey everybody, so this is just going to be a quick overview of some of the newer features that I've added to the engine over the past couple of months since I've last uploaded. There's a lot here that I've changed. A lot of the newer features are very low level, so it's kind of hard to describe and to go over. And it would take probably a video just for each of the features just to really go in depth, which I might do at some point, but I'd have to find the time between work and school and whatever else. So to start off, the editor's gotten a bit of a huge update. It's a completely separate application from the engine now, but I can go over that in a second once I start talking about some of the application framework. The first thing to really talk about that I started working on, I noticed that I was getting bogged down in small details, and so what I did was write out a game plan. Essentially, came up with a use case for a simple game that I wanted to create with my engine, and then marked out the big ticket items that I needed to knock out in order to get that implemented. The first thing that I noticed was that my asset system was severely lacking. I wasn't caching anything out. I just had free floating resources that were being called. So I really wanted to work on the asset system a lot more. So that was one of the first things I did. But when doing that, realized that in order to serialize anything out properly, I really had to come up with a good serialization mechanism, which that required me to have something that C++ doesn't give you automatically, which is good serialization and good, well, not serialization, but good introspection into C++ code. So, with that being said, the very first thing that I worked on was a reflection system for C++, well, for my code anyway. This kind of is very similar to Unreal's object method. The way that it works is, inside of my engine, anything that wants to participate in the reflection mechanism has to inherit from an engine object. And then when that happens, if you want to have it go through the reflection system, you have to mark it up with specific meta tag properties, like these here. So engine properties, class struct, stuff like that. If you've ever used Unreal, it's very similar to the exact same system. I can actually show you an example of something that's marked up. So if we look at a graphics component, it's probably good enough. Okay, so this is it's a graphics component. It's a public component. Component itself inherits from the engine object, so it will go through the reflection system, or at least it will inherit the object so that it has the possibility to go through reflection. It only starts to go through reflection once it's marked up this way. So for this, it's very simple. You mark up that it's going to be an engine class, so the type that it's going to be, it needs this specifically in front of the class so that the reflection system will see that tag and then know to start a reflection definition. The construct tag property here lets it know that it needs to have a constructor associated with the meta class that's generated for this class. And this class body here has a bunch of virtual function calls that are overridden, and then those are actually generated by the reflection system itself. This specifically here, I don't really like it, but it lets the reflection system know that this particular meta class is of type engine component. I do a lot of specific stuff for registering meta classes with the registry system and also unregistering those. A lot of that has to do with scene reloading, and it's just a lot of it's up in the air, and it's a little more complicated than I'd like to get into. But just as a brief overview, that's just how it knows that it's a component. If we come down here, we have a bunch of function calls. Those can also be registered with the system. You can have, just like Unreal, I could mark something up as an engine function, and then that will get registered with the meta system once it runs over it. If we look at this right here, we have an engine property. And essentially this works with most types that are registered with the engine. So if you have a class that's going to be introspected, and then you mark up any of the variables with an engine property, that gets, for the most part, most types work. There are a few use cases that do fail, which I'm working on currently. A lot of those have to do with templated classes, but for the most part, they work, especially on primitive types. So any of your, floats or floats, characters, strings, U8s, bools, any of that stuff. And then if we actually look at an example, some reflection code. So this is generated on compile. So what happens is the engine, when it compiles, it runs through a reflection program that I've created. So CMake will call this essentially. So I use CMake from a build system. CMake will make an out call to this program, pass in all the includes that it needs. So it runs through the entire include directory, which is all of these files here, and in any places that it sees where it needs to do any kind of reflection, it runs over those, and then it generates the reflection code for them. So again, there's a lot here, but all you really have to understand is that the stuff's just getting generated. And if we go down and we actually look at, let's say, the graphics component. Oops. Come on. So this one's very simple, but again, all the stuff I was saying, this is one of the overridden classes that anything that's being reflected has to override. And that lets it know how to actually construct the meta class so that it registers itself with the system. This is our constructor function, number of properties that this particular class has, and then the properties that are going to actually be inside of here. So we have a meta property, its type is an object, and that's the renderable that was marked up. The type, so the meta class type is a component, and then we give it a name as well. And then also this type ID is used all throughout the engine. It's generated at compile time, and it's used to register all types of things with all different types of systems. It's used to get the meta class information. So if you wanted to pass in to the object as a static function, give me the class of this, give me the meta class of this particular type, it uses this type ID in order to find that within the meta class registry, and then it returns you the meta class for that. It's not serializable safe because it is generated at compile time, meaning that if I remove a class or I add a class, there's a possibility that this would change. It would get knocked out of order. So it's not serializable safe, but it is runtime safe in that it won't change during runtime because it's compiled in. So it's used all throughout the system. This get class internal, again, all it does is if the class isn't registered, it'll register with the meta class registry, which this is essentially just a static class that holds all of the meta classes. It's pretty simple. So I register with that, and then it returns it. Type ID, again, it's a templated function call, which gets the type ID of a specific class. And that's pretty much it for the meta class system. But what's cool about this is that doing something like this, it's very simple to generate all kinds of different serialized methods, debug methods, basically anything you'd like to do in order to inspect a class during runtime. So this is kind of a simple thing that I wrote up using IMGUI. It's just I call it debug dump, essentially. It just takes any kind of object, just throws it in here, and it inspects its type, and then it outputs some IMGUI code depending on what that type is. So if we actually go to the top of the function here, grabs its class, prints out its type, and then for each of the properties in the class, it'll get a property, prints its name, and then depending on the type that's associated with that, it'll do specific IMGUI code. The specifics of that's not important, but all you need to know, of course, is that the reflection system makes this possible. Without it, this is impossible in C++. At least as far as I know. If anyone knows of any way, that'd be really interesting. But with this makes serialization possible as well. And with that being possible, then it was possible to actually do a caching system for all of my materials, all of my shader graphs, all of my textures, pretty much all of my assets that I wanted to have. So actually show an example of something that's serialized. Assets, cache. Okay, so these all run through, again, there's a lot of underlying systems here, but they all run through a byte buffer, which is essentially all that does is it goes through and it's for each type. Whoa, that's trippy. For each type that's in a meta class, it'll go through and it'll basically write that information in bytes out to a buffer, just a U8 buffer, and then saves that to file. So it's just a binary file. This is the exact same way that Unreal does it. Yeah. There's a possibility that I could have, instead of just doing direct to binary, could have done something like Unity does. We also do this at work, which is you have meta files that are associated with each of the binary files. I hate that system. It's just a lot of dependency. And also it really sucks for version control. You have to check in the meta files, and then you have to make sure that those are associated with the correct binary files. And then if you have someone that has a meta file checked out locally and it's changed, then it's a big headache. It's a lot easier, at least in my opinion, I could be wrong about this, but it's a lot easier to have a single binary file that has all the meta information together. You don't have to worry about keeping up with all this, meta file dependency crap. And on start, basically all I do, actually go into the asset manager, and its initialize function, if I could spell. So I have a cache registry. I like registries, apparently. But basically all it does is it iterates through the project directory, grabs all of the, let's see, this is initialization, read and manifest, yeah. So it looks for all the .easset files, which are it's my asset file name. Looks for all of those, and if it does, then it creates an asset record for it. Cool thing about this is that the asset records are basically just null wrappers. They record the UUID of the asset. This is all in the header for the asset whenever it's written out. Records, it reads in the asset UUID, the name, the class for the loader. Each particular asset has its own loader class. So shader graphs have their own class, textures do, meshes, all that kind of stuff. And then the file that particular asset was found, and then it just adds that record to the loader right here. What's cool about this is that, again, it's null, so it only reads in the record. It's a wrapper. It doesn't actually load it into memory. It's not until somewhere in the application that you request a particular asset from the asset manager that it actually goes through and loads up the asset. This is great because loading up is really quick. It's very fast to create these records. This also means that I'm not bloating my GPU with a lot of stuff. Right, if it's not actually being requested by the application, it won't be loaded. Yeah, so that's a definite win. So this is already a lot better of a system than I had before. I'm actually very happy with the asset management system. This is probably my favorite change that I've made to the engine so far. I think it's fairly robust, and there's a lot of changes that I want to make it even more robust, but it's definitely getting there. It's on a better trajectory than it was before, for sure. Okay. So applications is the next thing I want to talk about. all of the applications that will ever be created and that actually use the engine, all of them derive from the base application class. They have very similar functions that what you would see in Unreal or Unity or any other game engine, which is, you know, the initialization of the application, which is called once the game starts or the application begins. The update function, which gets a DT from the engine itself. Process input, which this might actually be a superfluous function call. I might be able to just keep that inside of update, and it's up to the user in order to create his own process input function. Haven't decided yet, but for now, this is there to be overridden, but it's not necessarily required. And then a shutdown function, which is required, which again, very simple, very straightforward. All applications have a name that are bound with them. These are not to be called directly. I hate that they're public, but it was the only way that I was able to get it to work correctly with the application system that I have. But I'll talk about this in a second, actually, once I start going over project creation. So that's essentially the base for all the applications. Not much to it right there, but then when we actually start to look at uses, if we go to the editor itself, all right, so the editor, you see it is an application. It has an init, update, process input, shutdown function. So this is the engine's main application once this is running. And this is essentially what we're looking at here, right? So all the different views, different windows, whatever else. What I like about this is that it's separate from the engine. I don't have to recompile the engine in order to make changes to this. It's very nice. It is tied to the engine in that it is part of the same solution, so they do have to recompile together, but it's not a huge deal for me, and I do like that the IMGUI, right, which I'm using here, is actually separated now from the engine. I wasn't totally 100% sure whether or not I wanted to use IMGUI for my editor, and I feel better about going down this route of it being a separate application. I start to actually develop the editor using IMGUI, and if somewhere down the road I decide that it sucks, it's very easy to create a new application, create a new UI framework if I wanted to in the engine, and then use that instead, and then compare the two. So far I haven't seen a need to do that. At work we used IMGUI for our editor, and other than some stupid stuff that we were doing, the performance was actually quite acceptable. So not a big deal. I'll probably stick with it. But I like having the option should I decide that I want to change it down the road. Okay, so cool stuff. This is where stuff gets cool. I think it is anyway. So over the past week, I was looking at scripting languages, right? So I had the asset management system working. I made some entity updates, some small updates here and there, but for the most part, the serialization and the asset management was a huge deal that I needed to knock off in order to start moving towards what I said previously, which was the simple use case of a game. All right, so that's working. Now what I'm looking for is scripting. I want some way to actually have games, separate from the engine, separate from the application. I want a script state that I can essentially write the game in, that I can use the engine in order to create a game. Very simple game. So I looked at a bunch of different scripting languages, anywhere from Lua, which I don't particularly like because I don't like dynamic languages. So I was looking at HackScript, I think it was called, which can transpile down into Lua. So I was looking at possibly having HackScript in here. I looked at TypeScript being transpiled into JavaScript using V8, since that's what we use at work, and that worked pretty well. I looked at AngelScript, a lot of different stuff. I didn't look at Python because Python sucks. But I went mainly between Lua and JavaScript. So I looked at Lua first, wrote up a small thing, which tested some Lua code. decided that I don't like the way Lua works, and then the hack script dependency. There's a good possibility that hack script will be null and void in the future, because who knows how long any independent project, open source or not, will be continued to be updated by anybody. So I kind of threw that away. Then I looked at V8. I mean, it's made by Google. Google's not going anywhere anytime soon. Then TypeScript, that's made by Microsoft. Microsoft's not going anywhere anytime soon. JavaScript sure as hell isn't going anywhere anytime soon, unfortunately. So that looked like that would have been a good solution. V8's a son of a bitch to try and compile. You can follow the steps that they have on their webpage, which I can show you here. I know this is a bit of a offshoot here. Let's see, you can go to their official V8 repository, come down here, check out depot tools, cool, you do all that stuff. As soon as you run this command, it fails. And it fails because of a Python script that's inside of the depot tools here in order to do the fetch call. Whether or not it's my version of Python that was failing, whether or not there actually is a bug within their script, I don't care. I don't have time to figure out someone else's build process in order to get something running. So that was kind of an automatic thing for me. I just didn't want to deal with it. We had problems building V8 at work as well. Our engine lead, was pretty much the one who was in charge of building it because he was the only one that knew how to. So I didn't want to mess with it. So what I did instead, I watched, for any of you who watch Handmade Hero, I think it's episode 22. I actually know the episode. Yeah, episode 21 and 22. So it's a great series if you haven't watched it yet. Casey Muratori, good guy to watch. He has, within the first few episodes, this episode 21 to 22, before he even starts doing any of the game stuff, he implements hot reloading C++, or C rather, since he writes it all in C. So he uses that essentially as his quote-unquote scripting language. He doesn't have any, dynamically compiled language that has a context and has to go back and forth between native and the script. No, he doesn't have any of that crap. What he has instead is all in native, using C as his scripting. I think that's awesome. So I went ahead and implemented the same thing. So as a preface to that, I'll show you a couple of things. Well, let's just go right into it. So the way this works is the engine, or the application rather, which is the editor. The editor takes in a project. That project has a DLL that's associated with it. That's an application itself. So the editor itself ticks its own application, right? So the engine's taking the editor's taking its own application. So it can change the runtime state of the application. It can reload and unreload that project, so the entire DLL, all the game state can be serialized and deserialized. That's including all the entities in it, the scene, any of that stuff. So if we look at an existing application that I have here, and I'll show you what this means. The application here is an object, so I can run that debug dump on it, right? So pass that in. Here's the type of the application, its name, which is another one, just the project name that I've created, and then some of its properties that were introspected here. I can actually click on this, and it's reloaded the application, but I can load its project. So I have attached Visual Studio to the editor, so I can load up any of the project solutions that I have. So if I look at this guy, all right. Here's its source directory. Let's go to its header file. So this is all generated by the engine wherever you're creating your project. I'll actually show that off in a second. here we have that again, that same reflection. It has it's an engine class, it's reflected, it's a type of application. It has an engine class body. This engine module body, this is kind of the stuff that I was talking about a second ago with having to have the unregister and register meta class information. This is actually defined in there. This has to be in this class in order for reflection to work for the application module. All of the methods that are overridden by base application or from base application are in here, and then we have the specific property information that's being marked up. So this one has an entity handle. It also has that time property and then the speed property itself. So again, if we go back and look at that, we can see that it has time and speed. If we go ahead and look back at this, I've also made it possible to create new components inside of any kind of application module. So here I'm defining a rotation component as a class body, as a component type of rotation component. Again, that just has to work for the entity manager in order to register this particular component. That works with the meta class information. Rotation speed and a rotation access are two of the properties that are marked up for it. And then a scale component, which, again, this is just throwing stuff together in order to make sure that I can create new components within application modules, load them into the editor, attach them to entities, and then playing and stop playing and have all the serialization work correctly. And then this module definition, these are actually exported functions. If we go into the engine code and look back at object, so these are the actual functions that get exported into the DLL that the editor needs to call, or anything that uses this DLL needs to call, which is the ability to create an application and then pass in the instance of the engine, and then the ability to delete the application. It's very simple. I could actually probably delete this here because this function itself calls this. So I really only need to have create and delete application, which is great. And then within those, creating the application, again, sets the engine instance. The reason it has to do this is because the engine is a static class, and static pointers don't work well across DLL boundaries. In fact, they don't work at all. So as soon as I delete the application, which happens on reload, so anytime I want to reload the application, it deletes the application, has to recreate all of these function bindings, then has to recreate the application. That means that the engine instance for this application is lost. So I have to fix up those pointers, and so that's what this is doing. And then it binds all the meta class information for that particular application. What that means is that if we go back and look at this guy, this works the exact same way that any of the engine code works. As soon as I build it, I can do that real quick. If it works, it should work. So you see that I'm actually generating reflection data here. It generates, yeah, I figured that was going to work. Oh, I'm in release mode, that's fine. Yeah, there we go. So you can't run a DLL, that's why I did that. But if we look at the output here, it runs over reflection down here, generates a reflection file, and then it finally generates the DLL. If I look at that reflected information, so this is all of the reflection information that this application module has generated. It's including the application itself. Also, this rotation component is in there as well, and then the scale component's in here as well. And if we look down here, we have bind and unbind application classes. This is when it's called. Whenever the application is being created, it has to bind this with the meta class system, and then whenever it's destroyed, it has to unbind this with the meta class system. Fairly straightforward. Okay, so what's cool about this is that trying to make this as extensible of an editor as possible, it's very easy to create a new project. So let me just create one and I'll go over what happens here. So if I create a new project, apparently that already exists. Let's go look. Sure enough, it does. Let's go ahead and delete it real quick. It'll leave me alone. Alright, there we go. So it runs through a lot of stuff and then creates a new project and then opens up that project solution for me. Set it to the correct configuration. It's my time. I'm okay. So if we look at here, again, all this has been generated by the engine. It's kind of the default stuff that you need in order to get this up and running, which I can do a build of it real quick. Runs over the generation, outputs the DLL and the PDVs. If I look at Enjon projects, you can see we now have a new directory here. Has an assets directory, a procedures directory, which just has some bat files, stuff like that the engine calls. There's a CMakes list. This Enjon project, this is actually collected at the start of the editor. It looks for this, and then it records the project path for this particular project. And then the source directory here. Inside of build, we actually have a generation folder. Inside of here, it has a reflection configuration folder. Basically, this just has some specific markup that the reflection system needs to use. The name of the project, whether or not it's an application, it needs to have app bindings generated, and then the different files that need to be reflected, and then the directory of the engine itself. And then we have intermediate files. These are the individual classes that have been reflected over. And then the linked file, which basically what it does is it takes all those individual files and then generates the one CPP file. And then that is actually used in the compilation for this DLL. So let's go back to the editor now that that's all kind of shown. And you also see down here we have in the existing projects tab, this diff1 has popped up. So that is a usable application. Whenever I click on this, it actually loads the DLL. So now any of the application state that was registered within the application is actually now loaded into the editor. And I can start making changes. I can actually start building a game now. So let's go back to another one, this other project. Let's load that up. And let's look at the world outliner down here. So what I wanted was the ability to create new components, which are essentially script modules that work on entities within a scene, and then be able to add those. This point light component here is an engine level component that's given by the engine itself. It's not application specific. These two here were application specific. These are tied to the application that's actually loaded. So this another one here has a rotation and a scale component actually inside of it. If I switch back to using the diff one, you'll notice that those go away because they're not actually in that particular application. So let's go back to here, and let's attach a rotation component to our entity here and a scale component. So the entities being reflected here, it has transform information, both local and world. The local transform is only different from the world transform if it's parented to something. The components down here, these are component IDs. For some reason this is garbage. I'm going to have to look at that. That's not correct. Children if it has any children, and then the actual components that are listed. And these are the actual pointers to the components. You see you have a graphics component which has a renderable. I can change his mesh to anything that I want. Anything that's actually registered as a mesh asset within the asset manager. But I'm pretty partial to the monkey, so let's do that. Material, I only have one material that's created right now, it's just this default one. And then the rotation component is also marked up, and you notice it has rotation speed and rotation axis. So if I change his rotation speed, see that he'll actually change there. And then the rotation axis, the axis that he's rotating upon. And again, these are marked up properties that are within that component. And again, the cool thing is if I go back to here, and I go to the rotation component, and let's say I want to add a new property. Let's just make it a color. Let's give it a burnt orange color. Okay, and then I recompile the DLL. This is always scary, doing compilation live. Alright, so we built the DLL. Now what we need to do is reload it. So I'll hit R to reload it. And there we go. Now the DLL is being reloaded, and the color is now down here. It's been serialized properly, reflected properly, and now it's actually in the DLL, and it's part of the rotation component. I can also come back here, and if I decide that I don't like that particular, where is it? That particular property, I can delete it, recompile, and again, this is all while the editor is running. Recompile it, and then reload the DLL, and now that property is gone. So very, very powerful, very cool. Last thing I want to show is I've actually written some stuff in the initialization function here. So for this, it describes the entity manager, the asset manager, creates an entity. This another one entity is actually a property that's part of the application. Again, the application is serialized, so you can have entities, you can have whatever else you want, any kind of game state, and it'll get serialized properly as long as it's marked up. And then it adds components to it, rotation component, graphics component, and then it just creates a bunch of children. This is actually probably too many, so I'll change that to 2,000. Creates a bunch of children, attaches it to the main entity here, which is just going to be it'll be the bunny that's in the scene. And then they all have rotation components, and they all get attached to the main entity there. So let's go ahead and reload. Okay, and then if I hit play, it'll actually run through the initialization and then start to update the scene. So now we can see that we have, from the application side, this bunny has been created. I just hit reload on accident. But to show that works, so at any point I can make changes to the application within the project, right? So that application DLL, I can make changes to that, save it, and then reload the DLL, and it will automatically reload, the game state being intact. So let me change the camera speed here so I can fly around. You can see all of the different entities here. These are all the children. They all have rotation components, mesh component, and they're all rotating around this guy, this bunny here, which I believe he is the second guy here. Yeah, so if I change his rotation speed, he'll rotate a little faster. And then if I change his axis, now they're all rotating, again, with respect to his transform. So, yeah, that's pretty much the, and then when I stop the scene, we clean up the scene and restore the scene back to where it was before, with the one entity that was actually associated with the editor, right? So yeah, that's pretty much the state of everything. So, alright, thanks for watching.